heat developed in a wire is H if wire is cut in two equal parts and joined in parallel, the new heat dissipated will be. Here, one resistor is connected to a battery whose EMF is V, resistance is R, then heat produced in resistor according to Joule's law is equal to V square by R T. Suppose now, once after cutting resistance into two equal parts, resistance of each part becomes R by 2. So when they are connected in parallel and same thing is connected to the same battery, what will be the heat dissipated across the resistor? Once two equal resistors are connected in parallel, effective resistance will be is R by 4. Now heat produced will be V square by R square by 4, which is 4V square by RT, which is 4H. Here a square magnetic field at the center due to a current carrying wire AB, and let me write this as O, BC, CD and DA. So magnetic field at O will be magnetic field at AB, magnetic field at BC, magnetic field at CD, magnetic field. Since it is a vector, what is the direction means? Put thumb in the direction of AB, finger shows out of the plane. So magnetic field at O due to the current carrying wire AB, even BC also, it is out of the plane, CD also out of the plane. All are in the same direction. So we can add numerically, that is 4 times BAB. So magnitude of magnetic field will be 4 times, that is 4 times. If a finite wire is carrying a current I and magnetic field at a distance D, this angle is alpha, this angle is beta, magnetic field at P will be mu naught I by 4 pi by D sin alpha plus sin beta. Here, since it is a square, if you drop a perpendicular, so he given this length as 1 unit, so it will be half, and this is 45, it's 90, here it is 45, even this also 45. So the magnetic field will be mu naught I by 4 pi, D is half, sin 45 plus sin 45. It is 2 mu naught I by 4 pi, 2 by root 2, which is 2 root 2 mu naught by 4 pi is a standard value, I is current. So 10 root 2 into 10 power minus 7. But magnetic field at the center is 4 times this. We get 40 root 2 into 10 power minus 7 Tesla. So X value here is what? In vernier calipers, 49 main scale divisions are equal to 50 vernier scale divisions. So 50 vernier scale divisions is 49 main scale divisions. One vernier scale division is least count or vernier constant. One main scale division minus one vernier scale division. 49 by 50 main scale. 50 minus 49, 1 by 50 of main scale division. Each one main scale division he given it as 0.5 mm. So it is 5 by 500, 1 by 100 mm, which is 0.01 mm. So in this circuit, potential drop in forward bias across silicon and germanium diodes are given as find the potential. Here, so potential drop, this is threshold voltage, he given it as 0.7 volts. That means here, suppose only silicon diode is connected, it is connected to a battery. Suppose if it is ideal diode, then here threshold voltage will consider as 0. Suppose since we mentioned here 0.7 volts, that means if the battery applied voltage is less than 0.7 volts, then current will not pass through this. So here applied voltage must be more than the threshold voltage. So here potential drop across silicon will be 15 minus 0.7 volts. Again, there is a further drop across this another diode, that is 0.3 volts. So potential at this point A will be, let us say, that will be is equal to how much 14. Let us say here from C, VC minus VA is equal to 14 volts. So now these two resistors are connected in series. R1 effective resistance will be 4 kilo ohms, that is 4 into 10 ohms. So now current through the circuit will be V by R, that is 14 by 4 into 10 power minus 3. So 3.5 into 10 power minus 3 amperes. What he is asking, potential difference across 2.5 kilo ohm resistor. So it is IR 3.5 into 10 power minus 3, 0.5 into 10 cube. Just get cancelled. 25, 375. So 8.75 volts. Here, Einstein photoelectric equation E is equal to h nu plus mu naught, that's work function, plus kinetic energy maximum. So this is h nu is equal to h nu naught plus kinetic energy maximum. So this slope of graph between stopping potential and frequency, stopping potential and frequency. Your Ke maximum is nothing but E into stopping potential. So EVS is equal to h nu minus h nu naught. So stopping potential is h by E into h nu naught by E. So stopping potential is taken along y-axis. So let us take frequency is taken along x-axis. So in place of m, what we have is h by E. So that is slope of a graph between stopping potential and frequency of instant photon. Here, this problem, I set temperature minus 10 degrees centigrade is converted into steam. So I set minus 10 degrees centigrade is converted to steam at 100 degrees centigrade. So ice at minus 10 to ice at 0 is same state. One stage it is, stage 1. Ice at 0 to water at 0 without changing temperature, change of state. This is stage 2. So here it is. Next stage, water at 0 to water at 100. This is stage 3. Your same state changes. From here, steam at 100. So here, without changing temperature, change of state. So here it is latent heat of fusion. This is latent heat of vaporization. So in first, till rising minus 10 to 0, there is a once according to the heat supply, temperature changes proportionally. And in second stage, at constant temperature, change of state occurs. Temperature is constant here. Third stage, temperature is rising with respect to the supply of heat. Fourth stage, change of state which occurs at constant temperature. Third one is suitable. Here, this graph we are familiar, but slightly different way. Now, both process cannot be isothermal if they have a same reference point. Here let us take pressure, volume. At fixed volume, let us say here P1, V1. At this point, volume is V2, pressure, let us say P2, V2. Again, here pressure is different. At constant temperature, P1, V1 is equal to P2, V2, P1, V1 equal to P3, V2. So, which implies P2 equal to P3, which is impossible. Here pressure and here pressure are different. So both cannot be isothermal. In the same way, both cannot be adiabatic. So one must be isothermal, other must be adiabatic. So it's a very simple observation. PV is equal to K. PV power gamma is K. Here P is K by V. P is K by V power gamma. As gamma is more than 1, V power gamma will be more than V. As denominator increases, pressure decreases. Obviously, more steeper curve represents adiabatic, right? So this one is isothermal. The same graph, if you extend upwards, what he given for us is these graphs he given. So in fact, graph what he given for us is like this. So this one is adiabatic, that is, and this one is isothermal. So if you name this as A, this as B, A becomes adiabatic. This is A, this as B. So A becomes adiabatic and B becomes isothermal. We know adiabatic equation and isothermal equations. So voltage across 5 ohm resistor, voltage across 50 ohm resistor is given as this. Find out the time required for current to change from I0 by 2 to I0. Okay. So this one, V here, voltage across resistor is 200 sine 100 pi t. So current will be V by R. It is 200 sine 100 pi t by resistance 50. So it is 4 sine 100 pi t. So the peak current is 4 amperes. So it is a problem similar to simple harmonic motion. There also a sine curve. A particle which executes SHM about mean position, here amplitude is 0, here amplitude is maximum. Time taken for one complete oscillation is T. For 1/4 oscillation, it is T by 4. From here to here, let us say here x equal to 0 to A by 2, time taken, if you can calculate, then T by 4 minus this will give you time taken the particle to move a by 2 distance to a. So let us take here x as that a sine omega t. Here I will write when particle starts from mean position equation, when amplitude becomes half of it. So omega t will be half sine omega t, which implies omega t is pi by 6. T equal to t by 12 seconds from here to here. From here to here it is t by 4 minus t by 12, t by 6 seconds. Here also same, from I naught by 2 to I naught, how much time means it is t by 6 seconds. So here time period is, he given angular frequency as 100 pi. So 2 pi t will be 100 pi. So t here is 50 to pi by t. T will be 1 by t. So the time period is in fact from half of the amplitude to maximum amplitude, that is t by 6, 1 by 300 seconds. Here point source. So field produced by radiation in all directions, right? Intensity at a distance r, intensity at a distance r is equal to p by, this is the definition of intensity. As distance increases from the source, intensity obviously decreases. So P is nothing but amount of energy incident per unit time. This is same every second. It only depends upon distance from the source. So I into R square is constant. I1 R1 square is I to R2 square. So at a distance 2 centimeters, intensity is I. At a distance 4, what will be the intensity means 4I by 16. That is intensity is I by 4. The nucleus of mass M breaks into 3 nuclei. Bigger mass breaks into 3 nuclei M by 3 with the same mass. Maybe they may move any direction by conserving momentum. So nothing to do with direction regarding energy. So by Einstein's mass equivalence relation, energy released is equal to, so its total energy gained by equal masses, that is m by 3 v square m by 3. Energy is a scalar quantity, nothing to do with directions. 3 times m by 3 v square. So this velocity of daughter nuclei here it is 3 mv square, which is equal to delta mc square. So v is equal to root of delta m by 3m into C. It is mass into half mv square, right? 2 delta m by 3m. Right. This is the answer. And here, momentum, here is energy, and velocity of light is 3 into 10 power 8 meter per second. Total momentum imparted to the surface, if completely absorbed by the surface, is equal to E here is this, C is that momentum is mass into velocity. Once you know the statements, you can answer these questions. So familiar one is Gauss law of electrostatics. Your flux through this one, it's very obvious. Flux is equal to integral E dot dA. So D maps to 1. You know about Ampere law. Ampere law, what it states? For any closed path, sum of length elements times the magnetic field in the direction of length is equal to mu naught times current enclosed in a loop. That is nothing but integral B dot dl is mu naught I. So Ampere law with maps to 4. Next, Gauss law of magnetic fields. So what it says is flux of a magnetic field through a closed surface is 0. That is integral B dot dA is 0. So mu maps to 2. Remaining obviously, so Faraday's law of whenever a conductor is placed in varying magnetic field, an electromotive force is induced. If the conductor is closed, a current use is induced. This is what Faraday's law of electromagnetic induction. With the help of these statements, we can answer this question. Power transmission line feeds input power 2.3 kilovolt to a step-down transformer. The output power delivered is 230 volts. So here, type of transformer is step-down transformer. So power is supplied at 2.3 kilovolt, that is V input is 2.3 kilovolt, that is 2.310 cube, so 2300 volts. So output voltage, power delivered at 230 volts. This is output voltage. The current in primary transformer is 5 amperes. Efficiency of transformer is 90%. What he is asking, what is output current? So if there is no transmission losses, power input is power output. But he said efficiency is 90%, then if no transmission losses. But in this problem, what he given is output is it's only 90% efficient. So V output, I output is 9/10. V input, I is primary. Input voltage is 2300, output voltage is this. Primary 5 amperes. What is output current? 230, 10 times. So output current is 45 amperes. Here two identical charged spheres are suspended by a string of equal lengths, which makes an angle 37. Let us assume it as theta, or let us assume it as 2 theta. The 2 theta here is 37 degrees. This one is here identical charges, let us say. The strings makes an angle 37 because so there is a force of repulsion. So angle of separation is 37 degrees. So what are the forces acting on the strings? One is tension in the string. So it becomes theta. The component of the tension, which is inch. So this component T sine theta. Force on this charge will be. Now balancing horizontal component T sine theta QE, that is force of repulsion between the charges, and T cos theta here is mg. So dividing one with other, we get tan theta is mg. So between charges, what is the medium means? Air. This is, and now the same setup is done in liquid of density. So here charges, the same thing is kept in a liquid instead of air. So what is, how they differ now? Forces, tension will be same. Here it is T cos theta will be same, but since it is kept in a liquid, there will be a force of buoyancy, upthrust, and here also it is T sine theta. Here force will be there. That force is nu force. When charges are placed in liquid medium of dielectric constant K, the nu force will be, so here what you get is Q1 earlier 1 by 4 pi epsilon naught Q1 Q2 by d square. Additionally, this K is the dielectric constant. So earlier that force here is 1 by 4 pi in air media Q1 Q2 by d square. So Fn by F will be the same thing. Here we get 1 by K. Now here let us balance the forces. T sine theta is F nu. In vertical direction, T cos theta plus force of buoyancy cent. From these two, T sine theta by T cos theta is F nu by mg minus Fp. Tan theta here is F nu by mg minus Mp. Say here it is first equation, second equation. So equating tan thetas, F by mg is Fn by mg minus force of buoyancy. Mg minus force of buoyancy by mg is Fn by F. So Fn by F here is 1 by K for S. Upthrust is equal to mg, that is m here is mass of the liquid displaced, volume into this is density of liquid. Here sigma is density of liquid. So now here D is so density of material. So VdG minus V sigma G by VdG is equal to 1 by K. Here Vg get cancelled, D minus sigma by D. So 1.4 minus 0.7 by 1.4 is K. K here is 1.4 by this. So the dielectric constant of a liquid is 2. Here in this problem, what he given, focal length of a convex lens is if the magnitude of the object distance and image is measured with reference to the focal points of a lens. So here, if you consider this convex lens, you have two foci, but two foci are at equal distance from optical center. So here when object is placed somewhere here, ray parallel to the principal axis. So after passing through the lens, right, after refraction it passes through principal focus. Any ray which passes through the optical center, it's undeviated, they intersect somewhere. Here you get image. This is an object. Here is f distance. This is also f. What he given is, let us say this is x1. Object is x1 distance from one focus. Image is at a distance x2 from the another focus. U here is minus of f plus x1. V here is f plus x2. So 1 by V minus lens formula, 1 by f plus x2 minus 1 by minus of f plus x1 is 1 by f. Actually, no need to derive this. It is a standard relation, but some people who don't know, they can also know through this derivation. Here it is f into 2f plus x1 plus x2 is f square plus fx1 fx2 plus x1 x2. After cancellation, 2f square becomes x1 x2. F here is x1 x2. You given a graph, if you observe this point, right? So x1 is at a distance of 20 from one focus. Y is a distance of from other focus. Then you have here f square by this formula 20 into 20. The focal length of a lens is 20 centimeters. A vector has a magnitude and power. Any vector parallel to 4i plus 3j is t times 4i plus 3j. But what he said, magnitude of this vector is same as magnitude of this, which is 5. So 16t square plus, which is 5. That means 5t here is t is 4. So the vector becomes t times 4i plus 3j, which is because t is 1. So he said x component is 4. What he's asking is only x component in one very simplest problem.